Line graphs and uniform circular motion. By the end of this topic, you will be able to describe distance-time graphs, describe uniform circular motion. The line graphs are drawn using two perpendicular lines on the graph paper. The horizontal line x, O, x dash is called x-axis and vertical line y, O, y dash is called y-axis. The point of intersection of x and y-axis, that is point O, is called the origin. Independent variable is taken along x-axis and dependent variable is taken along y-axis. Suitable scale of both the variables need to be mentioned on the right-hand corner of the graph. To select a suitable scale, following points need to be considered: the total range of the variables, the size and value of the smallest square of the graph paper. While plotting a graph, all the positive quantities are plotted on the right and upwards of the origin. All the negative quantities are plotted on the left and downwards of the origin. Distance-time graphs. In the distance-time graph, time is taken along x-axis and distance is taken along y-axis. Let us employ distance-time graph under various conditions. Distance-time graph for a body at rest. If an object does not change its position relative to a fixed reference point, body is said to be in a state of rest with respect to the fixed reference point. Let us consider a body at a distance of 8 meters from a reference point O. If the body is stationary, it will not change its position with respect to time. Therefore, the distance-time graph of the body at rest is a straight line parallel to the time axis. Distance-time graph for a body moving with uniform speed. When an object covers equal distance in equal interval of time, it is said to be moving with uniform speed. The table given show the distance of the body with respect to time for first 5 seconds. In this case, the graph of the distance and time is a straight line moving away from the time and distance axis. The slope of the graph gives us the uniform speed of the body. Thus, the uniform speed of the body is v equal to delta x by delta t equal AB by AC equal 10 meter per 2 second equal 5 meter per second, where delta x and delta t represent the small changes in the distance and time respectively. Distance-time graph for a body moving with a non-uniform speed. When an object travels with non-uniform speed, then the distance traveled is not directly proportional to the corresponding time intervals. Therefore, the distance-time graph of a body moving with a non-uniform speed is a curve. The shape of the graph depends upon the way the speed of the body changes with time. When the speed of the body increases with time, the slope of the distance-time graph also increases. In the given figure, slope of the graph BC by DC at any given point gives the instantaneous speed of the body at that point. BC by DC equal 8 minus 2 meter by 3 minus 1 second equal 6 meter per 2 second equal 3 meter per second. Whereas when the speed of a body decreases with time, the slope of the distance-time graph also decreases. Conclusions from distance-time graph of a body. If the graph line is parallel to the time axis when the body is at rest with respect to the reference point. If the graph is a straight line and not parallel to the time axis, then the body is moving at uniform speed. If the graph is a curve, it means the body is moving at variable speed. Uniform circular motion. The motion of an object along a circular path is called circular motion. The velocity of a body moving in a circular path at a constant speed changes continuously as the direction of motion changes constantly. The circumference of a circle of radius r is given by 2 pi r. If the object takes t seconds to go to once around the circular path of radius r, the velocity v is given by v equals 2 pi r by t. The change in velocity of the body gives rise to acceleration in the moving body. Therefore, even at a constant speed, circular motion of a body is accelerated motion. Few examples are motion of a stone tied with a strong thread and whirled in a circular path, motion of an athlete along the circular track, rotation of wheel about their axles, the moon revolving around the earth in a circular path at constant speed. Summary. Let us summarize what we have learned in this topic. Line graphs are drawn using two perpendicular lines on the graph paper. Independent variable is taken along x-axis and dependent variable is taken along y-axis. The distance-time graph of the body at rest is a straight line parallel to the time axis. If the body is moving with uniform speed, the graph of distance and time is a straight line moving away from time and distance axis. The distance-time graph of a body moving with non-uniform speed is a curve. The velocity of a body moving in a circular path at a constant speed changes continuously as the direction of motion changes constantly.